The first suit you should buy is a black suit. Black suits can go to everything. Every man has to own a black suit. After you get a black suit, there's 5 suits you need to get: black, navy, gray, brown, tan. You get those 5 suits, you get yourself 2 white shirts, get yourself 2 cream color shirts, and 2 powder blue shirts. You can make 75 suits with those combinations, because every last one of those pants go with every last one of those jackets. Every last one of the jackets goes with every last one of the pants. You cannot mess up.
So is Steve Harvey right? Can you make 75 different suit combinations with what he listed out there in that clip? If you use the counting principle, you can figure out if he's telling the truth or not. And before we start, remember, if you're not practicing this stuff outside of these videos on your own, you're only screwing yourself. You're not going to get better at something if you just sit here and watch someone else do it. So make sure you're taking the time to do that. Now, back to the counting principle. The definition of the counting principle, and this is probability related, is that if one event can occur X different ways, and another event can occur in Y different ways, then the two events can occur together in X times Y number of ways. So here's a quick example, is that if you're at Chick-fil-A, let's say, and you want to put together your own combo meal, so an entree, a side, and a drink. How many different ways could you do that given all of the options on their menu? Well, they got 8 entrees, 7 side options, and 10 drink options. So all I'm going to do to get all the different combinations that I could get is I'm going to multiply the different ways that each one of those items on the combo can be chosen. So I have 8 entrees I can pick from. Those are all your sandwiches and wraps and everything. Multiplied by 7 different sides, and then times 10 different drink options. 8 times 7 is 56, times 10 is 560 different combos. So put in short, take the number of different options that you could pick from for each item on the combo and multiply them all together, and that's how you get your answer. So let's use the counting principle to see if old Steve is actually right. He tells you to get 5 different suits. Black, blue, I can't remember all of them. You can watch the clip at the beginning. But there's 5 different suits. And a suit comes with a jacket and a pair of pants. So really what we have here is 5 different jackets that you could pick from and 5 different pairs of pants you could pick from. He then tells you to get 6 shirts, right? 2 white, 2 cream colored, and 2 powder blue. Well, yeah, there's 6 shirts, but there's only 3 different colors, and that's what we want. So we'll have 3 different colored shirts. That's just in case one of them gets dirty, you have a backup. All right, so we have 5 different ways that we could pick a jacket, 5 different ways that we could pick a pair of pants, and 3 different ways that we could pick a shirt. So what do we do with those numbers? We multiply. So 5 jackets times 5 pants times 3 shirts. 5 times 5 is 25, times 3 is 75 different suit combos. So good old Steve was right all along. So something else you might come across in your probability adventure is tree diagrams. And in addition to rolling dice and drawing cards from a deck, you'll often find yourself flipping coins for fun when studying probability. So if I take a coin and I flip it 3 times in a row, what's the probability that it lands heads all 3 times? Let's say the first flip lands heads. Well, what could happen after that? Well, I could get a heads, or I could get tails, right? So let's stick with that path. So we get heads on the first flip, then heads on the second flip. Well, what could happen after that? Well, on the third flip, we could either get another heads or tails. Follow this path down here. After I go heads, tails, what could happen after that on the third flip? Well, I could go and get heads or tails on that third flip. So we could go heads, heads, and heads. That's one option. We could get heads on the first flip, then heads on the second flip, and then tails on the third flip. Or we could go with heads first, and then tails second, and then heads third. And we could go heads first, then tails, and then tails on the third flip. So here we have 4 different possible outcomes when flipping a coin 3 times, and assuming that the first flip is heads. Well, what if the first flip isn't heads, it's tails? Well, just make your tree diagram, list out all the different paths that that could happen. So let's say after you flip tails, well, what could happen after that? You could go heads or tails on the second flip, and let's say we go tails and then heads. Well, what could happen on the third flip? You could go and get heads, or you could get tails, and then same thing down here. So if we list out all our paths again, I could go tails, heads, and heads, or I could go tails, heads, tails. I could go tails, tails, heads. Just put that over here. Tails, tails, heads. Or I could go tails, tails, and tails. So again, we got 4 different outcomes when we get tails on the first flip. So altogether, I have 8 possible scenarios or events, and we only want to consider what's the probability of it landing heads all 3 times, which is going to be that path in light blue there. So there's 1 out of 8 possible events that is favorable to us in this problem. So we could say the probability of getting heads, heads, heads on 3 coin flips is 1/8. Using the counting principle, you could look at this problem a little bit differently. We could say, all right, let's say the first event, right, is you flipping the coin for the first time. Well, how many different ways could that go? Well, you're either going to get heads or tails, so there's 2 different ways. If you flip it then a second time, how many different ways could it go? It could either go heads or tails again. So 2. And then on the third flip, you're only going to get a heads or tails. So again, there's only 2 different ways that third flip can go. So that gives you, again, 8 possible outcomes, or 8 possible combinations of heads, tails, and flipping the coin 3 times. And if you're smart enough to recognize that heads, heads, heads is a unique event, right? There isn't another instance of heads, heads, heads. That only happen. That's only one specific type of event. Then you know that only 1 out of those 8 possible outcomes is the probability for getting heads on all 3 flips.